Hello students, I am Dr. Ritu Agarwal from the Department of Electronics and Communication Engineering. Today I would be discussing the circuit realization using different multiplexer and decoder. Along with this, we would be discussing barrel shifter and arithmetic logic unit. So we would be starting from circuit realization using multiplexer. So the very first circuit we would be realizing that is using multiplexer. So the very first circuit is 8:1 multiplexer using 4:1 multiplexer and 2:1 multiplexer. And since we have to implement 8:1 multiplexer using 4:1 and 2:1 multiplexer, and in 8:1 multiplexer, how many selection lines are required? We require 2 to the power 3 is equal to 8. Therefore, the selection lines required will be equal to 3. Since we have 2 to the power 3 is equal to 8. And since we have to realize 8:1 multiplexer, so we need 3 selection lines. And if we are using 4:1 multiplexer, in case of 4:1 multiplexer, we have only 2 selection lines. And in case of 4:1 multiplexer, we have 4 inputs and 1 output. And in case of 2:1 multiplexer, we have 2 inputs and 1 output. So for the first case, since we have total number of inputs as 8, so obviously we would require 2 4:1 multiplexer. In one multiplexer, we have 4 inputs. And in another also, we have 4 inputs. So total number of inputs are 8. And that is the requirement of the 8:1 multiplexer. And selection lines are 2. So both the selection line S0 and S1 will be connected to both the multiplexers. And since in case of 8:1 multiplexer, we have 3 selection line. So one selection line is given here to the 2:1 multiplexer. Because when we are connecting these two 4:1 multiplexer, we have 2 output. But in case of 8:1 multiplexer, we require only 1 output. So to select one output at a time, we require this 2:1 multiplexer, which will be connected to the output of the two 4:1 multiplexer, and whatever be the value of S2, depending on this, we will get the output of 4:1 multiplexer. So if the case is that S1, S0 and S2, if the case is 0, 0, 0, so which output would be selected? If I have 0, 0 here and for S2 equal to 0. So in this case for S0 and S1, output selected will be here. For the upper one, we will be selecting 4. And for the lower one, we will be selecting A0. And when S2 is equal to 0, then which output will be selected? This. Since S2 is equal to 0, then we will be selecting the lower output, that is equal to 0, or we have output equal to A0. So this is the case in which we can find out the values of value of y at the output of 2:1 multiplexer. Similarly, we can see another example if we have 0, 0, 1. So in this case of 0, 0, 1, what will happen? S0, S1 is equal to 0, 0, 1. Means for S0 it is equal to 1. And for S1 equal to 0. So for 0, 1, we have output as A5. And here the output will be A1. And if S2 is again 0, so the output will be A1. So for this case, output is A0. For this case, output is A1. Similarly, this will go till 1, 1, 1. So we can see 1, 1, 1 also. For S0 equal to 1 and S1 equal to 1, we have 1 and 1. So in this case, we will find out which output will be selected. 0, 1, 2, 3 means from here for the upper one, A7 will be selected. For the lower multiplexer, A3 will be selected. And in both the cases, for A3, here you will get A3 and here you will get A7. And since the value of S2 is equal to 1, so the upper one or the upper output will be, input will be selected, and therefore the value of y will be equal to 7. So for 1, 1, 1, which output will be there? A7 output will be there. So this will be the realization, or this will be the working of 8:1 multiplexer. And in this manner, we can draw, or we can implement 8:1 multiplexer using 4:1 multiplexer and 2:1 multiplexer. Now we come to another circuit, that is full adder using 4:1 multiplexer. Now what is a full adder? Full adder is a circuit which can add 3 number of bits. If I say A, B and C in, which is called as the carry in, and outputs are sum or S and carry out or C out. So in this case, how many combinations are possible? 8 combinations are possible. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1. So these are the 8 combinations which are possible. Out of this, for the sum will be 0. Carry will also be 0 for the first case. For the second case, sum is 1. Carry is 0. For the second, third case, 0, 1, 0, sum is again 1 and carry is 0. For this case, 0 plus 1 is 1, 1 plus 1 is 0. So this is, we have 0 and carry out will be 1. For the next case, for 1 plus 0, we have 1 and carry is 0. For 1 plus 0 plus 1, 1, 0. So the sum is 0 and carry is 1. Then the next case, for 1, 1, 0, again 0 and 1. And for the last case, we have 1, 1. So from here, from this table, we can see that for the numbers 1, 2, 4, and 7, the sum is 1. While for 3, 5, 6, and 7, the carry is 1. And therefore, we have written 1, 2, 4, and 7 for the sum, and 3, 5, 6, 7 for the carry. So we will be realizing it with the help of this decoder. So with the help of this decoder, we can write 1:1, 2, 4, 7 and 3, 5, 6, 7. These are connected with 1 is connected, 1, 2, 4 and 7 are connected to one sum, which is one OR gate, which is giving the sum, and another OR gate, which is giving the carry. So this is the circuit or the full adder using decoder, in which we have sum and carry. These are connected to 1, 2, 4 and 7 to the sum, and 3, 5, 6, 7 to the carry. Now we come to another circuit, that is barrel shifter. Now what is a barrel shifter? It is a digital circuit that can shift a binary number by a specified number of bits in one clock cycle. It is commonly used in digital signal processing, cryptography, and microprocessor architecture. So this is the block diagram of barrel shifter. In barrel shifter, we use, since we are having 4 number of multiplexers, and 4 multiplexers are 4:1 multiplexer. Each multiplexer is 4:1 multiplexer. So here we have 4:1 multiplexer, 0, 1, 2, 3. So the inputs are connected in such a manner that it would be acting as a shifter. Here the bits or the outputs will be shifted depending on the value of this S0, S1. Now if S0, S1 is equal to 0, 0. So for the first case, this is connected to W3, 0. So if output input selection lines are 0, 0, the output will be W3. Second case, for 0, it is connected to W2 and therefore the output will be W2. For the third case, it is connected to W1, so the output is W1. And for the fourth case, Y0 will be equal to W0. Now, if the selection line is 0, 1. Now, if 0, 1 selection line is there, then in that case, 1 will be selected and 1 is connected to W0. So here we will have W0. For the second case, 1 is connected to W3. Y1 is connected to W2 and this last Y0 is connected to W3. So here we can see there is a shift or the cyclic shift of the outputs. W3, W2, W1, W0. Now this W0 is shifted to the first position with the help of this barrel shifter. W3 is shifted here. W2 is shifted here. W1, sorry, this should be W1. W1 is shifted at this place. If I have 1 0 as the input, for 1 0 as the input, then 2 second input will be selected and Y3 will be equal to W1. This will be equal to W0. This will be equal to W3 and this will be equal to W2. So again, there is a cyclic shift in this. So this is the way the barrel shifter is going to work, or this barrel shifter will be working. Next, we come to the another topic, that is arithmetic logic unit. Arithmetic logic unit is the fundamental component in a computing system like a computer. It is basically the actual data processing element within the central processing unit in a computing system. As we have already studied in previous classes also, that arithmetic logic unit is nothing but a logical unit which can be used in central processing unit. So it performs arithmetic and logical operations, and it is considered to be the backbone of the modern computer technology. So in arithmetic logic diagram or arithmetic logic unit, block diagram is shown over here with the input data and control signals are there. And at the output, we have some data which is being controlled with the help of some inputs. Now, there are different features of arithmetic logic unit. First of all, it can perform all the arithmetic and logic operations such as addition, subtraction, multiplication, division, logical comparison, and etc. It can also perform bitwise and mathematical operations on binary numbers. Now it contains two segments. First segment is for arithmetic unit and the second segment is for logic unit. It is the computational powerhouse within a central processing unit. ALU is the part of every central processing unit where actual data processing takes place. Now, ALU is responsible for interpreting the code instructions based on which operations to be performed on the input data. Once the data is processing is completed, the ALU sends the outcomes to the memory unit or the output unit. Now, there are different operations which can be performed. First operation is arithmetic operation. Obviously, in arithmetic operation, it includes addition, subtraction, multiplication, division of binary numbers. And all these operations form the basis of mathematical computations that the arithmetic logic unit can perform. Then it can also perform some logical operations. What logical operations it can perform? It can perform AND operation, OR operation, NOT operation, and several other operations. Then it can also perform the comparison of the numbers, that is equal to, not equal to, less than, greater than. All the comparison operations can be done. Then the last is the shift operation. It can also perform the shift operations, like it can shift the binary numbers to the left or the right. Uh, Shift operations are important in case of multiplication and division operations. So shift operations can manipulate binary data at bit level and hence optimize the arithmetic calculations. So this is all about our arithmetic logic unit. These are the references which we have used. Thank you.